Welcome to Oryx Learning. Today's lesson is going to be on Unit 4, Systems of Equations, Lesson 2, Solve by Graphing. Let's first take a look at Jamal. Jamal sells woven baskets at the market. He sells each basket for $10. He borrowed $20 from his parents to purchase tools, and it cost him $8 per basket for materials. He wants to know how many baskets he will need to sell before he starts making a profit. We can find the solution with a graph. So if we let y represent the dollars and x represent the number of baskets sold, we can form an equation for the revenue, y equals 10x as he makes $10 per basket, an equation for his expenses, y equals 8x plus 20, as it cost him $8 in materials per basket and he borrowed $20 from his parents. Graphing these lines, we can see that they intersect at the point 10, 100. The intersection point is where he will break even. Therefore, Jamal needs to sell 10 baskets before he will start making a profit. What is the intersection point in the graph shown below? We can see that the intersection point is at an x value of -10 and a y value of +6. Coordinate points are written in the form x, y. The x-coordinate corresponds to the horizontal axis, and the y-coordinate corresponds to the vertical axis. So in this case, we have the point xy, or -10, 6. Graph the given equations. Y equals -3/4 x plus 4, and 4x plus 2y equals 14. The y-intercept in the first equation is the b value of 4, so you want to place a point on the y-axis at 4. So we go to the point 0, 4, and we place our point. The slope is down 3 and to the right 4, so we want to draw another point that is down 3 over 4 from the original y-intercept. Now that we have 2 points, we can connect the 2 points with a straight line. And there is our first line, y equals -3/4 x plus 4. For the second line, we have 4x plus 2y equals 14. To graph the equation, we first want to solve for y. In order to isolate the y, I need to subtract 4x from both sides of the equation, which leaves me with 2y equals -4x plus 14. Next, I'll divide both sides of the equation by 2, which leaves us with the equation y equals -2x plus 7. So now we'll start with the y-intercept, which is the b value, or 7. So we'll go to the point 0, 7, and place a point. And then we'll go down 2 and to the right 1 for our slope. After we have the 2 points, again, we can connect the dots with a straight line. Find the solution to the given system. Y equals 3x minus 2, y equals -1/2 x plus 5. Graph both the lines using y-intercept and slopes, then find the point of intersection. Remember, the point of intersection of a system is the solution. So in this case, in the first line, we will start at a y-intercept of -2, and then from there, we will go up 3 to the right 1 for the slope of 3, and connect the dots. For the second line, we will start at the y-intercept of +5, so we'll start at the point 0, 5, and then go down 1 to the right 2 for our slope of -1/2. Connecting the dots again, we can see that the point of intersection is 2, 4. So the point 2, 4 is the solution. In order to check our work, we can put 2 in for both of the x's and 4 in for both of the y's to make sure it satisfies both equations. In the first equation, we'll get 4 equals 3 times 2 minus 2, or 4 equals 6 minus 2, which gives us 4 equals 4. So the point does satisfy the first equation. In the second equation, we'll get 4 equals negative 1/2 times 2 plus 5. Simplifying, we get 4 equals negative 1 plus 5, or 4 equals 4. This means that it satisfies both equations, so the point 2, 4 is the solution to the system. Find the solution to the given system. X plus y equals 3, and y equals negative 3 times the quantity of 2x minus 1. In the first equation, we need to get it into slope-intercept form to graph, and I will do that by subtracting x from both sides of the equation. Simplifying, this leaves me with y equals negative x plus 3. The second equation I need to simplify as well, so I need to distribute and simplify the negative 3. So negative 3 times 2x gives us negative 6x. Negative 3 times negative 1 will give us positive 3. So now we have the line y equals negative 6x plus 3. In order to graph the first line, I'll start with the y-intercept of positive 3, and then use my slope to go down one to the right one and connect the dots. In the second equation, I will start with the y-intercept of 3 again, and then use my slope from there to go down 6 over 1, and once again connect the points. We can see that the point of intersection is at the point 0, 3. So 0, 3 is the solution to the given system. Jack graphs a line using the equation y equals 4x plus 2. He graphs another line that provides no solution. What is the slope of the second line? Remember that lines have no solution, have no points of intersection, and lines that have no points of intersection are called parallel lines. We know that parallel lines have the same slopes. No solution means that the two lines do not intersect. They must be parallel, and the slope of the second line must be the same as the slope of the first. Any line with a slope of 4, which is the slope of our original line, will cause no solution. So for example, y equals 4x minus 5, y equals 4x plus 10, or y equals 4x minus 8. All three of those lines would give us no solution with the original. So remember, when solving systems by graphing, first we must write both lines in slope-intercept form. Next, we will graph both of the lines. Third, find the point of intersection. And then last but not least, check that the point makes both equations true. That is our lesson for today. Thank you for joining us.